So back to the very beginning, up to the middle of 19th century, it was thought that heat was an invisible, weightless substance called caloric fluid. So back in the middle of 19th century, heat is called caloric fluid. So what is caloric fluid? So caloric fluid is a hypothetical fluid substance that was thought to be responsible for the phenomena of heat. So yes, that's caloric fluid. And in 1798, an American scientist named Benjamin Thompson Rumford disapproved the theory of caloric fluid. So for him, heat was produced from friction alone. So this American scientist, Rumford, he doesn't believe the theory of caloric fluid. So he doesn't believe that caloric fluid is the responsible for the phenomena of heat. So for him, heat was produced from friction alone. So friction is like you're rubbing two things together. So for example, like this. So you're rubbing your palm all together. So when you rub it like that, there's a heat, right? So that is friction. So that is what Rumford believed. So heat comes from here by rubbing. So by rubbing two things together or through friction. But 40 years later, an English physicist, James Prescott Joule, proved that a measurable amount of mechanical energy could always be transformed into definite amounts of heat. So any mechanical energy can produce or can be transformed into heat. He concluded that heat must be just another form of energy. So this English physicist, he believes that mechanical energy can produce or can be transformed into heat. Not just friction alone can produce heat, but also mechanical energy. So he also concluded that heat is another form of energy. So since he concluded that heat is produced by mechanical energy too, he added to his conclusion that heat is also a form of energy. So yes, that's it. He was the one who concluded that heat is a form of energy. So that's the history of heat. So now let's define what is heat. So heat is a form of energy which flows from higher temperature to lower temperature by conduction, convection, and radiation processes. So these processes of heat, the conduction, convection, and radiation, will be discussed later. Okay, so let's go back to heat. So heat flows from higher to lower temperature, right? So for example, the sun radiates heat to warm up the planet Earth. So when the sun produces heat, when it comes down to Earth, it's not really that heat, it will cool down. So sun releases a higher temperature of heat, so when it comes down to Earth, it will lower down. So it's not really that hot anymore. Okay, so that's how, that's the example of the process heat flows from higher to lower temperature. Okay, so now let's define temperature. So temperature is the thermal state of a body which controls the flow of heat from one body to another and determines the direction of heat flow. Okay, so temperature is the one who will measure the heat you have in your body and also the one who will control the flow of heat from one body to another. So temperature is also the one who will determine the direction of heat flow inside of our body. Okay, so now let's talk about the sources of heat. So we have two sources of heat. We have natural sources and artificial sources. So in natural sources of heat, we have two categories. So first, the heat from the sun, and second, the interior of the earth. So the heat from the sun, it's the main source or natural source of heat. So when the sun energy reaches the earth, so it's when the sun energy reaches the earth, 30% of it is immediately reflected back out into space. So only 70% remains to interact with the earth and warm it up. So in the 100% heat comes from 100% heat comes from the sun, only the 70% of it will remain in earth and warm up the surrounding, the environment, or the human. So the 30%, so we have 70% here, so the 30% will go back to space. So the 100% will not come all together here, only the 70% of the heat energy. So the second natural source of heat is the interior of the earth. So a great amount of heat also comes from buried hot rocks and lava flow from craters and crevices of erupting volcanoes. So another sources of natural sources of heat is the volcano inside the earth. So interior of the earth. So now let's go on to the artificial sources of heat. So we are done with the natural sources. So natural sources, we have the heat from the sun and the interior of the earth. So now we have artificial sources. So in artificial sources, we have a four categories. So first we have chemical action, mechanical action, electric energy, and nuclear energy. So chemical action is when fuels like coal, kerosene, wood, and gasoline are burned, they are used as artificial sources of heat. So example of this is bonfires, right? So it produces heat. Okay, so the oxygen we breathe in burns the food we eat, producing enough body heat to keep our body temperature close to 37 degrees Celsius. So 37 degrees Celsius is the normal temperature, right? Okay, so that's chemical action like bonfire or something like that. So number two, we have mechanical action. So mechanical action is the heat energy produced by a friction. So I already mentioned friction a while ago. So friction is, right, so rubbing like two things together or palms all together. So yeah, rub it like that and you can feel the heat, right? So that is mechanical action. So third, we have electric energy. So very common. Electricity is a very common source of heat at home. So yes, electricity. So example of this. So now let's move to the types of scale. So we have three types of scale. So first we have Celsius scale, so very common, Celsius, and Fahrenheit scale, and Kelvin scale. So first let's talk about Celsius scale. So what is Celsius scale? So Celsius scale, commonly known as centigrade scale. So Celsius scale, it is also known as centigrade scale. So this scale was devised in 1741 by a Swedish astronomer, Andres Celsius, based on the properties of water. So Celsius scale was produced by Andres Celsius. So the name of the scale was named after his name, right? Andres Celsius scale. So he devised this in 1741 and based on the properties of water. So please refer to the picture. So that is the Celsius scale. So that was devised in 1741. So another scale is the Fahrenheit scale. So Fahrenheit scale. So the Fahrenheit scale was devised by Daniel Gabriel Fahrenheit, a German physicist. So just like the first scale, it was also named after the inventor. So Daniel Gabriel Fahrenheit and Fahrenheit scale.
As the continuation of our topic today, I will be discussing the three types of heat transferred. Heat is the energy that is transferred from one object to another as the result of a difference in temperature. There are three ways to transfer heat. The first is conduction, second is convection, then the third one is radiation. The conduction which occurs in solid or fluids that are at rest, such as this metal bar. Heat is transferred by direct contact. Solid are the best conduction of heat. Last is the transmission of the heat from partite to particle. The second form of heat transfer is the convection, which occurs in liquid or gases, which is in motion. Convection, this is the process occurs in liquid and gases. Heat is transferred by the movements of currents, and the last is the transport of heat within a substance by the actual movements, the substance itself. Radiation is the transfer of heat through electromagnetic waves. The heated substance is not necessary. The difference between heat and temperature. Heat, it is a form of energy in motion. It is the cause of temperature. It does not determine the direction of flow of heat. And the last is, it is measured in joule or calorie. While the temperature is, it is the degree of hotness or coldness of a body. It is the effect of heat and also it is determined the direction of flow of heat. It always flows from a body at a higher temperature to a body at a lower temperature. And the next is, it is measured on the Celsius, Fahrenheit, or the Kelvin scale. We have five causes of heat. The first is the sun, petroleum, natural gas, coal, and the last one is the solar energy. These five are the main causes of heat. These five also are the causes of temperature. Results of heat and temperature. Heat is equivalent to Q is thermal energy transferred from a hotter system to a colder system that are in contact. Temperature is a measure of the average kinetic energy of the atoms or molecules in the system. We can calculate the heat released or absorbed using the specific heat capacity C. The mass of the substance is m, and the change in temperature is T delta T in the equation. Here are the some example of heat transfer.